Welcome to Section 5 of the midterm study guide for Physics 135B. Three identical resistors are connected in parallel and powered by an adjustable voltage source. The voltage and total current measurements are shown below. Determine the value of R. So the value of R is the individual resistance. So we're going to sketch what we think the circuit looks like. This is an example of graphical analysis. And we have three parallel resistors powered by some voltage source. Now, voltage sources, epsilon, give a total current through a total resistance. That's Ohm's law. I could have just as easily said delta V equals IR. But that's R total, right? That's not the individual resistance in some piece of the circuit. That's the total resistance. So our task is to vary the voltage. It's been plotted here on the y-axis, and then gather the current data, and then plot it so that we get the linear trend. And if the y variable is placed, on the y-axis and it's the voltage, and then the x variable is placed on the x-axis, and that's the current, then the slope should be the resistance, that's the total resistance. So from this graphical data, we can know the total resistance. All we have to do is extract the slope. It's not hard. The data is quite linear. So let's go ahead and look at this particular point. If it's 600 volts divided by 6 amps, then I think the slope, which is y divided by x in this case, that's 600 volts divided by 6 amps, and so it looks like it's 100 ohms is the total resistance. So just remember our total is 100 ohms, but remember these are three identical resistors connected in parallel, so we actually know how to relate our total to the individual resistors, because this is the rule for how parallel resistors are connected and related to their total resistance. So that's R total equals 3 over R. Now we have to flip the formula upside down. Do not forget that minus sign is there. This is 1 over R total is equal to 3 over R. So let's solve for R. So R over 3 is equal to R total. And so R is equal to 3 times R total. So this individual R is equal to 3 times R total. But we know R total is 100 ohms. And so that is 300 ohms is the value of each individual resistor. And notice that those resistances are larger than the total resistance. So it's like adding three things equals some number that's less, right? And so don't get it confused, right? Because if these resistors were in series, and each of them had a resistance of 300 ohms, then you would have 900 ohms of resistance. But that's not what we have. We have three of them in parallel, so the rule is actually that rule. So the answer is 300 ohms for the individual resistors. Now, using the PHYS135B tool for DC circuit construction, design a circuit in which a battery with fixed voltage lights a bulb, but the bulb brightness can be dimmed or brightened. So I think, there are obviously very, a variety of ways to do this. I would say get a battery, and then obviously you're going to have to hook to some bulb. Let's just draw a bulb like this. And then do something next before returning back to the negative terminal of the battery. So here's the light bulb, but then the light bulb has to be, it has to have some resistance. But if you give it more current, then obviously, if you give it more voltage, then it will be brighter. But I think you can do something in here to change the voltage decrease across specifically this part of the circuit. So if you plot the voltage, let's say this is 0.1, 0.2, and 0.3. This is voltage, and then we'll just say 1, 2, 3, representing the positions in the circuit. here we start at epsilon. We have this many volts. It could be 10 volts, 12 volts, whatever it is. But we start at maximum, and then we go to 0.1, and we haven't lost any volts yet. But as we go across the bulb, we're going to drop down some volts, right? And then as we go across anything else that we put in the circuit, we're going to drop down some more. But the point is, we have to drop to 0 because we have to consume all the volts, right? You have to conserve energy. So according to Kirchhoff's rule, loop rule, if we were to go around the circuit, then we have to account for all the volts, right? So if we gain some epsilon of volts in going from here to position 1, as we go from position 1 to 2 to 3, then we have to lose all those volts. If we gain them, we have to lose them, because the total, if you go in a circle, should be 0. So here is the change in voltage for the light bulb, the V bulb. So if we wanted to control how many volts are lost in going across the light bulb, I think what we have to do is change the resistance here. And if we change the resistance there, then we can actually change, like the remainder of the resistance will be, or the remainder of the voltage change will be dropped across the bulb. So let me give you an example. Let's say we have a massive resistor right there, a very big resistor. Well, that means there's one current, and so whatever the current is, if we have a big resistor, then let's say this is a situation where the current is going to remain fixed. Now that's obviously not that's not as realistic as I'm making it sound. But let's start with that and see what happens. If we make the resistor very large, then the voltage decrease going from here to here will be large if I is fixed. But the thing is, that means that the voltage change, if the voltage drop across this resistor here were very large, then the graph would look like this. Like there'd be very little decrease in delta V bulb, and all of it would be dropped across the big resistor. But if we had a tiny little resistor there, then for the same current, then there'd be relatively little, voltage decrease across that resistor, but most of the voltage would be dropped across the bulb. So what you can do is design a circuit that will have variable resistance. So let's go to the simulation tool, and what we'll do is we'll place a battery, and then a wire, and then a bulb, and I'd like a switch just so I can control whether it's on or off, and then another wire to come from the bulb. But now I want a resistor, and let's take a resistor here and then close it with a wire, and let's just see what happens. Let's see if this is a weird a model or if this actually works. So if I close it, of course the battery will power the bulb. Some of the voltage will be dropped across the resistor, but if I change the resistance to nothing, right? If I lower the resistance, the bulb will get brighter. But if I raise that resistance, the bulb will get dimmer. So I have a way of controlling the brightness here. I have a knob that allows me to control the brightness without changing the battery. So that idea that you can vary the resistance of a thing, that's called a potentiometer. And potentiometers are used for creating analog dials and things like that. For knobs that allow you to tune voltages and brightnesses of bulbs in circuits. So that concludes the study guide for the midterm of 135B. Please email me at jhansen2@whittier.edu with any additional questions. Thank you.